This is video 5.2.1. We're looking at section 5.2 in your book, which deals with the sum and difference formula. In this video, we're actually going to find exact values of trig of angles that we're not familiar with, that are not on our unit circle. But we're going to use these formulas to allow us to find those values using the values that we have on our unit circle. So that's our ultimate goal, is to find exact values of angles using these formulas. So what's really interesting about these formulas is they're 2 in 1. They combine a formula for the sine of u plus v, that's using the top symbol, will equal the sine of u cosine of v plus, because it's the top symbol, cosine of u sine of v. Okay, so that's one. To get us started, we need to understand these formulas. So the first understanding you need to have is that there are 2 formulas in 1. Now remember, these formulas are still in the back of your book. They're still going to be allowed on tests. You do not need to memorize them, but you do need to know how to use them. So what's really important here is now we work with the second symbol in both parts of our formula. So the second formula is when we're working with a difference of u minus v, we get that answer by doing sine of u cosine of v minus cosine of u sine of v. So it may or may not be helpful for you to write down these formulas, but you need to make notes that cosine is interesting and tangent is interesting as well. They flip up these symbols. So notice when we add the 2 angles, we're actually going to subtract them over here. And then when we subtract them, we would actually add these 2 quantities. So those symbols are aligned because they're both on the top or the bottom of the formula. So in tangent, we have multiple times where the symbols show up. We're going to add the angles for the tangent of u plus v. It will equal the tangent of u plus the tangent of v all over 1 minus the tangent of u tangent of v. Then the other symbol is when we're subtracting the angles, we'll subtract on top and add on bottom. So that's important to understand the symbols and to be careful and cautious when you're solving these problems, because the #1 mistake you'll make is just copying down the formula incorrectly. So let's start with problem solving, how to find the example answer, the cosine of 75. We're trying to find an exact value, so that means that there's going to be square roots and or addition, subtraction problems within it, but we're going to have an exact, concise answer for cosine of 75 degrees. So the way we start this out is we notice we're going to use the cosine formulas. We got to figure out how to separate 75 into a sum of something or into a difference of something. So for instance, right away I see that 75 degrees is equal to 90 minus 15. That's helpful because I know all of my trig values for 90 degrees, but 15 degrees I do not know. So this is not going to be the difference I will use for my formula. I'm going to find a different sum or difference. So I try something else. For instance, I could try 60 plus 15. Once again, that's half helpful because I know everything about 60 degrees, but I do not, once again, do not know about 15 degrees. So I keep looking for a way to add or subtract to 75 degrees. Then I stumble upon 45 plus 30. I know everything about those 2 angles. I know the sine, cosine, tangent, cosecant, and so on. So I'm going to use 45 plus 30 as my u and my v. So u is going to be 45 and v is going to be 30 because they add up to 75. So I'm pulling down the formula from above. I'm going to use the cosine of 45 plus 30 will equal, so I'm going to use my plus here, so I'm going to use my subtraction here. So cosine of 45, cosine of 30, minus the sine of 45, sine of 30. Now I look to my unit circle because I know the values for cosine of 45, for 30 degrees, for 45 degrees. I know the sine. So I'm going to use those values from my unit circle. So According to my unit circle, the cosine of 45 is square root of 2 over 2. The cosine of 30 is square root of 3 over 2. Minus the sine of 45 is square root of 2 over 2. And the sine of 30 is 1/2. Now it's just simplifying. I have an exact answer for cosine of 75, because that's what all these are equal to, according to the left-hand side of my equation. But now I need to simplify, because in order to get a proper answer, I need to make this as simple as possible. So I get square root of 6 over 4 by multiplying these two fractions, minus, multiply these two fractions, I get square root of 2 over 4. This can be written slightly simpler. Common denominator of 4, square root of 6 minus square root of 2. Simpler answer, easier to read, shorter. This is the cosine of 45. Quick check in your calculator, you could plug in both these values, left and right, and see that their decimal values are equivalent. We'll talk more about that in class if you don't understand. We're going to look at 3 more examples before you get some checkpoints. So next example, we have a value in radian mode. So we have pi over 12. Now many of us are not quick with our fractions, and even I would prefer to work with degrees, because I'm quicker with my adding and subtracting of whole numbers than I am with fractions. So my first step here is to change pi over 12 into degrees, because this will equal the cosine of the same angle in degrees. So I'm going to change this to degrees by using my process of 180 over pi. This will give me 180 over 12. Pi's cancel, which is 15 degrees. So I have a value for degrees that is the same size as my value for radians. So if I find the cosine of 15, it'll be the same as the cosine of pi over 12. So now I'm going to use my formula and carefully decide, is it an addition or subtraction? I'm going to use this formula. And since 15 degrees is so little, it's probably going to be a difference. Because it's so tiny, I wouldn't be able to add to 15 degrees using my unit circles unless I looked at negative angles. So in quadrant 1, I see 60 minus 45 is equal to 15 degrees. So I'm going to use the cosine of 60 minus 45, where 60 degrees is my alpha. Notice we're using alpha and beta for these formulas. And the 45 degrees is my beta. And I'm going to use the difference formula. So I'm going to use subtraction here and addition here. So I'm going to continue on and plug in my values that I know. So this equals the cosine of 60, cosine of 45, minus the sine of 60, sine of 45. Now I'm going to replace them with equivalent values. I know the cosine of 60 degrees is 1/2. The cosine of 45 is square root of 2 over 2. Minus the sine of 60 is square root of 3 over 2. And the cosine of the sine of 45 degrees is square root of 2 over 2. Now, this is the 3rd time I'm making this video, and now I'm seeing my mistake. Anyone else see it? I should have done addition. Thankfully, I'm not too far. I can change it right now. So kudos if you saw that before I did. But I'm going to change that to addition to make it right. Now I'm going to continue on and find the value. Square root of 2 over 4 for the left fraction, plus square root of 6 over 4 for the right. Once again, nicely I have the same denominator, so I'm going to get a nice answer. Square root of 2 plus square root of 6 all over 4. This is your final exact answer for the cosine of pi over 12. That is what you will be doing for all of these problems. Let's try a couple more examples. They get a little bit trickier, but we're once again going to go straight from radians to degrees for example number 3. So I'm going to take 7 pi over 12, and I'm going to convert it to degrees by doing 180 over pi, and I'm going to get 105 degrees. Okay, 105 degrees. So I'm going to work with 105 degrees, and it looks like I'm doing the sine of 105. Remember, we want to stay in quadrant 1 and find an alpha and a beta that either add or subtract 105. Since it's bigger than 90, I'm probably going to do addition. And in this case, you're going to do addition of 60 plus 45. Okay? You're going to work it out and decide to use the addition formula, which means I'll be adding the sine of 60 cosine of 45 plus the cosine of 60 sine 45. I'm going to replace all of these with the values that I know. Square root of 60. Sine of 60 is square root of 3 over 2. Cosine of 45, square root of 2 over 2. Plus cosine of 60, 1 over 2. Times sine of 45, square root of 2 over 2. I'm going to simplify my fractions. I'm going to make it into one fraction because it's a simpler way to write this sum. And this is your exact value for the sine of 7 pi over 12. Now, one more example actually works backwards. This one's interesting and you might really like this. Remember, pause this. Go back if I went too fast. Try some of those things like converting this angles to degrees that you saw here, if that helps you find the solution. So let's take a look at the final example for your checkpoint. Notice this is backwards. This is going to be important for verifying identities, to recognize that this is a formula you know about. This is a formula like this one, because it has sine of an angle, cosine of an angle, minus, cosine of an angle, sine of an angle. So because it was minus here, it should be minus over here. This quickly converts, recognizing that 80 is going to be your alpha, 20 is going to be your beta. I'm going to quickly convert this to an equivalent value, which is the sine of 80 minus 20. Well, that's just the sine of 60, which, according to my unit circle, is square root of 3 over 2. Plug it into your calculator. Verify that they are equivalent. If you plug this in your calculator, you should get the same decimal as if you plug square root of 3 over 2 into your calculator. Make sure you're in degree mode, of course, otherwise it won't work. So that is going backwards. You'll see some of that in class as well. So bring this example in so you can use it to pull from. Right now I want you to try 4 checkpoint exercises. They're in your textbook, so you're going to want to open up your textbook to these problems. So find the questions labeled checkpoint questions and complete the following problems, 1, 2, 4, and 5 from the pages listed here. Pause the video, restart it. Remember to bring your questions into class.